the bottom that just shows the recording has started, and I just want to let you know that that is why. Okay, so I'll be doing this for each of our sessions. All right, so I am going to open up our PowerPoint for today so that you can follow along with me. All right, and that should pop up for you in just a second. All right, so I want to start off today, and you feel free to stop me at any point. You can unmute yourself or just comment if you have questions, okay? Just kind of going through the stuff that we should have due today. So as you know, you've been working on this stuff all week. You've got the week 3 lecture, you had your week 3 homework, the week 3 quiz. Last I checked, most of you had completed all of these things. The portfolio project, some of you gave me drafts via email, some of you submitted it on Blackboard, both of which are fine. If you ever want to send me something in email first to get some feedback before you submit it on Blackboard, you are more than welcome to do so. I have a couple of you that I still need to get back to today with the edits on those portfolio projects. So I would look for those after class probably, or maybe later this evening even. As soon as I can get some work time to keep going with those, I will. Okay. So today your drafts for the part 1 and part 2 were due. You'll be working on more of this portfolio project going forward. Some of you already completed more than just parts 1 and part 2, which is great. I would urge you to keep moving forward. If you're on a roll, keep going. Work on part 3, work on part 4, work on part 5. This is a big project. The separation of the parts going week by week are really just a pacing guide, and it's just to kind of give you an idea of, okay, here's where you should be. We don't want you to fall behind. So use those as a guide, but again, keep moving if you're feeling in a groove, and I'll keep checking all the parts that you have completed as we're going on. The week 3 check-in, these check-ins or reflections that are always part of your weekly work, they do count in something in your grade, so please do make sure that you are completing those, and I am reading those, and I am responding and reaching out if there's something that we need to discuss. And I do appreciate the comments and the feedback about the course. This is obviously the first time we are doing a course like this, right? Completely remote. So there's definitely a lot of kind of snags that we may come across, but I appreciate everybody's response and I appreciate everybody's commitment to the course, even though we are doing this quite differently than we expected. All right, so this is going to be some things that I kind of want to hear from you. These are topics from week 3 that I did find were a little bit of a struggle for some of you, but understandably so, because it wasn't really that much of a focus, I think, in your weekly work. And you guys are going to find that as you're going through. And I know a couple of you mentioned that in your reflections. The course is not perfect by any means. There are some topics that I think are asked about, but not necessarily focused on very much in your text or in your lectures. They are small in comparison to the big topics that they're trying to get you to cover throughout the week. So don't stress yourself out about it. They're little intros to some of the topics. If I can try to find more of those things going forward in the course that are lacking within the lectures or lacking within the textbook, we can try to hit up more of those in our Saturday sessions. But I don't want you to stress out about, a term or something that you come across that you're not quite confident in. Do your best with it. Reach out if you have a question. Google can also be your friend. Don't forget about that. So anything that you're not finding in the text or in the lectures, please look for outside sources, ask questions, and don't stress yourself out about it. It's a work in progress. The course is relatively new in this format, especially very new. So that is why I do appreciate the feedback as well. One thing I'm thinking of specifically, the linear versus exponential, like I said, was just touched on, but also they started talking about points, which I know one of you mentioned, I think Megan maybe, within one of the quizzes, and it was not really talked about very much, but it was only one question. So I just don't want you to stress out, but again, I appreciate the feedback. So I want you to look at the difference between linear and exponential. And I'm not even going to answer this yet because I want to hear from you and see your thoughts on it. I don't want you to comment on anything yet. Okay, I don't want you to talk out loud. I don't want you to put anything in the conversations. I want you to just take a few minutes by yourself, maybe even write it down, the difference between the linear and the exponential, what that means to you. And then once you kind of have an idea of the difference between the two, I want you to try to answer these real world questions. So there's 4 of them. I'm giving you very basic examples, but I want you to answer, would this be a linear or an exponential relationship? Okay, so take a few minutes and do that. and I will pop back with you in a second. right, everybody, let's come on back here. So can you guys see the screen right now? Okay, see the PowerPoint?
It's blacked out in the top corner.
Yeah, to see the conversation, so each time a conversation goes off or I need to switch screens, for some reason the PowerPoint just goes away. I was able to pin it last time and I'm trying to figure out how we did that. So you may see it go, but it should come back. It's just if I need to get to the conversation, I have to minimize it. So that's why you might see it changing size, okay? So I'm going to go back to this here in a sec, and I'm going to keep my video off just for now because, again, I feel like that lag is a little bit worse if I keep the video on. All right, so the difference between the linear and the exponential. I do want to try to hear from one of you if you can try to explain, or you can put it in the conversation bar if you'd like. Any volunteers try to explain?
Linear is like the straight line, you're adding the same amount by continuously, and then exponential.
I think this is Megan talking. Megan, I don't know about everybody else, but I can barely hear you. I know you're talking, but I can't. It feels like you're real far away. Do you want to try again?
Like linear is you're just continuing in a straight line, adding the same amount, and then exponential, you're doubling it.
Okay, good. And that's much better to hear you, by the way. Yeah, so I'm going to touch on two parts of that, which the linear part was very, very good. So linear, when you think about the actual graph, that's going to be a constant change. So the word constant, and I see that Abby, you included that in your explanation too, is very, very important when we're looking at linear. So if you were to actually graph it, what would a linear graph look like? And feel free to unmute or comment. Smooth, that's a good word to explain it. Yeah, a straight line, very good. And you may remember going back to, I'm going to bring up like 9th grade maybe, 8th grade even, it could be earlier than that, that you very first learned about graphing and graphing lines. So when you learned about those types of lines, anytime you graphed a line, it could be vertical, it could be horizontal, it could be diagonal, but as long as it was a line, if it was a straight line, a constant rate of change, they called it, it ended up to be this linear type of relationship. So that's what you want to keep in mind is that constant rate of change. It goes up or down the exact same amount every single time. All right, now exponential, Megan, you mentioned the word doubling, which is a good example. So it's not every single type of exponential change is going to be double, but double is a good one. So you could have double, you could have triple, you could have it getting smaller, right? So it could go down by a half or a third. So it could be anything along those lines. Anytime you think about exponential, you want to think about the fact that it's not a constant change in terms of adding or subtracting. It is something that usually changes with the same percentage, or it usually changes with the same fractional amount every single time. But if you were to add or subtract a number, it won't end up to be the same amount because that amount that you are taking the percentage of changes every single time, right? So in these examples that I have in the PowerPoint, I'm going to pull that back up in case you can't see it for a sec. Looking at those examples, so the first one, a $50 deposit into an account every week. Hopefully you chose linear. Okay, if you're making the exact same, very good, the exact same amount every single time, that's linear, right? Constant. So that would be like a plus 50 every single week. Now, what about the 4.25% interest compounded annually?
Exponential.
That would be exponential. Very good. So anytime you see percentage, think exponential. The difference is you're going to take 4.25% of whatever was in the account. What's in the account is going to vary. So that 4.25% is not going to be the same every single time. It's going to be a different amount, okay? How about 5 people are infected each week?
Linear.
Very good. That's going to be linear. So regardless of the number of people that are infected, this would be saying that you're going to add on 5 people to that list every single week. That's a constant change. How about the number of people infected doubles? Good, that's going to be exponential, okay? So the exponential, we talk about doubling, we talk about percentages, okay? Now, I do want to talk about, just for a couple minutes, this that we're living, obviously, because it actually very much relates to this topic. A lot of my high school students actually are kind of commenting on this type of thing too, because it's a topic that we discuss in the algebra courses in high school. And that's the idea of this exponential curve. So we've seen on the news this curve that they continue to show us, and this idea of trying to flatten the curve. And this is why we're doing what we're doing. That curve is going to be different depending on what area of the country you live in, what area of the world you live in. The rate at which it increases or decreases is going to be different depending on the area and depending on how much people kind of listen to the suggestions that they're asking us to take. But these are all exponential growth and exponential decay models. Okay, so it's increasing or decreasing at a certain rate. What they're trying to do is slow the rate, okay, or change the timing of when it actually hits its peak so that we can handle it better. So this exponential idea, we're saying, okay, maybe it's not specifically a double, but using that as an example, in some weeks we may have seen it double. 2.5 times the number of people infected or 3 times the amount. And they want that number to eventually slow down so that we can handle it, right? The math behind it. And if you actually go, look at Google, there are so many math applications to this right now that teachers are using these models for you to really kind of understand the math behind it and to look at that curve. So this is a horrible but real example of we're living it right now is this exponential growth that we're trying to slow down the rate. Okay. So anytime you're dealing with percentages, doubles, triples, fractions, think about exponential. We are not going to see that much linear growth in the real world because things are not necessarily constant very often, right? Think about temperature, not a constant increase or decrease. Money in your bank account, even though we'd like to think there's a constant input into that account, okay, yes, you get your paychecks, but the money coming out is not necessarily going to be constant. And a lot of you talked about that in the part 1 and part 2 of your projects, where I'd like to set up a budget. I'd like to have a constant idea of what's going to come in and what's going to come out. But the realisticness of that is you can't, right? You can try. And that's why you're trying to come up with example budgets. You're going to try to figure out what's coming in versus what's coming out. But you also have to plan for the unexpected. Okay, and that's why we can't necessarily look at budgets as some type of linear, constant relationship. This is going to be something that is fluctuating depending on life. There's too many outside factors to say that this is what's going to happen every single time. Okay, and most of you definitely understood that point and went through the different examples of how it could change. All right, so that's one big one I wanted to talk about from week 3. Let's go back here and talk about what's expected for week 4. So week 4, if we look at just kind of recommended due dates again and pacing, we would want to try to have these things done by the time we meet next Saturday. So you have your week 4 lecture, which is actually very short this week when you go through that, but you have a lot of references in the textbook that will help you. We're going to be talking all about probability during week 4. Now that might be something you say, great, I remember that for the most part. I kind of get that. A lot of probability is working with number sense and kind of, I guess, common math sense, but there's also some real math involved behind it. So it's kind of a combination of the two. The textbook will really help you with that. We'll go through some practice ones today, but I think your textbook is definitely going to be a good resource. You've got your week 4 homework and your week 4 quiz as usual in my math lab. A lot of you did take advantage of the help features this week with your homework. Please do continue to take advantage of that. Use the, ask my instructor through my math lab, so that way it'll attach it to the question that you're working on. All right, your portfolio project, keep working on that. So you'll have parts 3 and parts 4 that are going to be due for next week. Part 3 and part 4 are not too bad. And if you have started working ahead, some of you have already completed parts 3 and 4, and you know that, or at least you've looked ahead to see what you need to do. My suggestion to you again, which I mentioned before, is if you're on a roll with it, just keep on going, okay? You should be able to answer most of the questions in the portfolio project already. You could probably finish, for the most part, the project if you wanted to, but this is your good pacing. All right, you have another project this week. The week 4 project is the standard coin report. I know it seems like you just did a project last week, but that was the week 2. We're kind of playing catch up. So those little projects that you have are every other week. So you have one at week 2, at week 4, and at week 6. The standard coin report is going to be pretty much all probability, and all you'll need to do that is a coin, which I'm sure everyone has one laying around somewhere. So you're going to want that because you're actually going to be testing out some things with probability with doing a coin flip. And then you have the week 4 reflection, okay? Now, this is something that I will be getting back to you more on. And you may have, I'm not sure, correspondence about this from the school, and feel free to speak up if you know more than I do. Um, we have a lot of emails to sift through, as you can imagine, with all of the changes that are going on. So I'm trying to figure out if they have pushed the date at all for the end of our session. Does anybody know for a fact? Maybe you've got more than I do.
I don't know.
Okay. In the
I know they
last,
changed the date of the beginning of the next
yes,
session.
yes, that's what I found too. And that's the only thing I could find so far. So I don't know. I got kiddos yelling in the background, sorry. Um, she had juice. She's very excited she had juice, if everyone would like to know. So yeah, I see that the next session has been pushed back. So, but I haven't heard anything about adding on time to this. My concern is that because we lost the first couple weeks, if you keep going with this 1 week at a time, you are going to run out of time if they have not changed the end of session date. So right now, our last session is scheduled for April 25th. Technically, if you look at going a week by week with these sessions that we've had, that means you'll have week 6 and week 7 due on that April 25th date. So what I would suggest to you right now, and I'm again going to try to find out more about what they're doing with end of session, is try to get ahead in your weekly work so that you're not crammed at the end of the session. Okay. Keep going on the portfolio project as much as you can. Keep going in your weekly work. If week 4 is a little bit easier for you in terms of topic and lecture and quizzes, then keep going. Jump into week 5 and see how you do. If you have questions at any point, if there's topics that we haven't discussed yet, reach out. We are in uncharted territory, obviously. Okay, I know this isn't ideal, but if that date is not pushed, I just want to make sure that you're not super, super stressed at the end of the session. Okay, so whenever you have time to get yourself a little ahead, do it. And then as soon as I have more updates, I'll let you know. Okay. All right, I know I had a couple comments while I was talking there, and I can't read at the same time, so let me just see. Little typo there is a good one, Abby. So Abby, you're back right now. I had my screen on my PowerPoint, so I didn't even see that you left and came back there. But it looks like you are back now. Hopefully we are good. And don't forget this is being recorded, so you can always go back and watch whatever you miss. Okay. All right, so that is, oh good. Okay. So that is kind of my just warning, okay, because I don't want you to be stressed out. So please just make sure you're looking ahead and spending some extra time. All right, topics. So let's start talking about week 4. Is there anything that anyone wants to ask or talk about with your week 3 work before I kind of jump into talking about week 4? And like I said, I'll be getting back to the rest of you today on that portfolio project with your edits or congratulations, you did a fantastic job. Okay. All right. So,
I know
and
I still have to get mine in.
okay, yep, and that's no problem. And again, the pacing, like we said, recommended. I just want you to try to get as much done as you can. All right, so this is just going to be, oh, I'm sorry. Go ahead.
I was say it's a little tough when it took me 5 hours to do just the quiz and 8 hours to get through the homework.
Yeah, and
I didn't have time for the rest of the stuff during the week.
understandable. Yep, and
It
like I
was
said,
really tough week.
life, trouble with the topics. And like I said, well, you probably didn't read my email yet. And this is to everybody. Sorry, kids are coming in. I don't ever want you to be spending that long. 1 second. I'm sorry. Kiddos have a tough time not being able to hang out with me when I'm right downstairs. It's hard when you can't leave the house. I'm sorry. Hold on. All right, the screaming is starting to calm down. She's 2. She's having a hard time understanding this. All right, so this probably is just not cutting out the sound either. All right, husband's trying up there, trying. All right, so let me talk about probability a little bit. All right, so intro to probability. In the beginning of your week 4 lecture, you're going to see 3 big topics here that are going to talk about theoretical probability, empirical probability, and subjective probability. These are things that you may want to jot down now so that they are a little bit more familiar with you when you start to go through the lecture, or certainly just take notes or do the print of the voiceover notes from your week 4 lecture. But the terms sound a little bit scarier than what they actually are. Okay, so theoretical, empirical, subjective. You're also going to see the word, I think they call it classical within your work. And basically that just means classical is like what somebody outside of the math world. Oh my goodness. Oh boy. Skype is tough. It's tough. Classical is somebody outside of the math world, what they might kind of think of when you just do a probability question. So if I just ask you, what is the probability of flipping a coin and getting tails? What might you say?
50-50.
Yeah, okay. And I heard different answers. And thank you for trying to participate through my screaming. You may say 50%. You may say 1/2. And most people, regardless of their math background, are kind of going to get that because that's like your classical probability. That's also called theoretical probability. Theoretical is saying based on the theory of just what the coin looks like, what the setup is of the coin, this is what should happen. So if I flip a coin, there's a 1 out of 2 chance that I'm going to get tails. There's a 1 out of 2 chance that I'm going to get heads, right? Because that's the way it's set up. That's theoretical probability, okay? That's classical probability. Now, things that you can't necessarily answer with theoretical or classical are things that don't have clear-cut setups, okay? Like when you talk about the weather, that's not something I can really do theoretically or classically because it's not something that's cut and dry, right? A coin has 2 sides. So it makes sense that I would either have a 1 out of 2 chance to get that heads or that tails. There's a lot of other things that you're going to look at in this week that are kind of cut and dry, but then you're also going to talk about empirical and subjective, which are those things that are not necessarily cut and dry. Okay, so you have theoretical, you have empirical, you have the subjective. Theoretical is going to be your easy, what should happen. All right, empirical, that's going to be, okay, I know what should happen, but empirical is what actually does happen. So if I say that there's a 1 out of 2 chance, that implies that if you flip the coin 2 times, 1 will be heads and 1 will be tails. Will that definitely happen if you pick up a coin and do that right now? Not necessarily.
No.
Right? Yeah, it may, and theoretically it should, but empirically it may not. So the empirical probability is more based on I'm going to do it. I'm going to actually do it and see what happens, okay? And that's actually what your project is going to be about this week is the standard coin report. So you're going to be flipping a coin a certain number of times, and you're going to record how many times do I get heads, how many times do I get tails, and you're going to look at the empirical probability. So empirical is really based on observations and kind of trials to actually see what actually happens, all right? So theoretical, again, is what should happen. Empirical is going to be what actually does happen when you test it out, okay? Subjective, this is going to be something that's a little bit more based on personal experience, and this is going to be kind of like a judgment. So based on my morning, I could have given you a subjective probability, and I could have said the probability of my 2-year-old screaming in the background is about 95%. That's my personal opinion. This is not a cut and dry theory. This is based on how my morning went. This is probably what's going to happen, right? So that's a subjective, personal probability. And Abby, I think you're right along there with me today. All right, so that's the difference. So I want you to understand the terms that go along with each one. All right, I'm going to have you take a second, maybe jot those things down in your own words and have it as a resource as we do the next activity. So I'm going to take a 2-minute breather and have you jot those things down, and then we'll come right back and keep talking about probability. And you don't have to put it in the conversation. This is just for yourself to have it as a resource. I want you to know those 3 words. And I'll put the PowerPoint back up so that you have those words to look at. All right, I was trying to help Tatiana get back in. She lost her connection there for a second. I'm going to give her 1 more minute and see if she can hop back in before we keep talking, okay? Give me just 1 sec.
Oh, okay, thank you.
There we go. Yeah, I can hear you now. Good. All right, so back into the probability topics. All right, so the answers to probability are always going to be fractions, decimals, percentages. So these are the three that you should be comfortable with in this week's work. You should be able to kind of go back and forth between the three. So the coin toss is kind of the easiest one to think about, and that's the 1 out of 2, right? So if you think about that as a fraction, that would be 1/2. And some of you guys, when I just asked you that question, answered 1/2. Some of you answered as a percentage by saying 50%. So you should know some kind of common conversions that deal with fractions, and that will definitely help you to be able to answer some of those questions. But you also just need to be able to take any fraction, any decimal, any percent, and convert them back and forth. Okay, so I'm going to go back to our Skype call here and pull up a whiteboard, and we're just going to try a couple. So we're going to convert between the three. So if you have a sheet of paper or something, it would probably be helpful for you to write these down so that you have them as a resource. Okay, so we're going to look at just converting back and forth. So first one we're going to look at is I'm going to give you a decimal, and we're going to take that decimal and we're going to change it into a fraction, and we're also going to change it into a percentage. So let's start easy. So if I give you the decimal 0.25, that's probably one that's common. So most of us probably know that 0.25 is the same, think about money, is the same as saying a quarter, right? So if I were to answer that as a fraction, I would say that this is going to be equal to 1/4. So 1 out of 4. So when you think about probability, that's saying the probability of something happening would be 1 out of 4. Now, I can take that and very easily change it into a percentage as well. So we know that you're just moving the decimal point. So if I move that to the right, then that would be 25%. So you should understand that those are three different ways to represent probability. They all mean exactly the same thing, but you need to be okay with each one. Decimals, fractions, percentages. Okay, let's try a decimal that's a little bit harder. So 0.25 is a common one. Let's do 0.68. So this is going to use, I guess, information about place value within your decimals. I think that would be the easiest way to understand this. So when you have the first spot of a decimal, this, remember, is called your tenths place. This is called your hundredths place. So if we say 0.68, the real way of reading that is actually 68 hundredths. So if I show that as a fraction, I could say that's 68 out of 100. But you probably also know that 0.68 is the same as saying 68%. And you can also think about it that way, that each percentage is out of 100%. So that makes more sense to kind of say that that is 68 over 100. Now, most of the time, leaving your fraction like this is probably fine, okay? But you are going to see some questions, especially multiple choice style, or maybe in a question where you need to input your response. Maybe they'll ask you to put it in reduced or simplest form. And this is going to bring you back to, if you did take Math 101, some of the topics there where you worked with reducing fractions and equivalent fractions. So that is something that you should know how to do. To me, the easiest way to do it is just to start by dividing by a number that you know goes into both, regardless of how many steps it takes you. So if I just want to simplify or reduce this fraction, 68 over 100, well, I know that both those numbers are even. And if a number is even, I can divide it by 2. So if I do that for each one, so 68 divided by 2 is 34. 100 divided by 2 is 50. Now, I ended up with even numbers again, so I could do this again. Both of them are divisible by 2. So 34 divided by 2, I get 17. And 50 divided by 2 is 25. Now, these numbers are no longer even, so they're not divisible by 2, but I'm going to see if I can divide these by anything else to try to get them down further. I usually check even numbers divisible by 2. Odd numbers, I try to look at, okay, could I divide them by 3? Could I divide them by 5? So I'm kind of checking those different things. If a number ends in a 5 or a 0, it is divisible by 5. That's a good little trick. So this could definitely divide by 5 and get down further, but I can't do that with 17. 17 is what we call a prime number. There's no other factors of 17, which means this is as far as I'm going to go. So this is the reduced version of that 68 over 100. So you probably need to be comfortable with both, depending on the question. Okay? So that's taking decimals and changing them into percentages. Let's try one more of those. I think I can scroll down. Give me one sec. Lost my scroll. I'm just going to clear. Okay. All right, let's do whoops. Okay, 0.8. So if we do 0.8, I could read that truly as 8/10. So 8/10, I could word that as 8 over 10 as a fraction. If you think about 0.8 with 2 spots instead of 1, technically it's 0.80. So if you weren't sure how to read that 0.8 as 8/10, you could always say that this is 80 out of 100, or you could say 80%. All right, now if I do 80 over 100, that eventually would just reduce to that anyways. So if you do know your place value, it might just make writing these a little bit quicker and easier. But I can still reduce that 8/10. So 8/10, both of them are even, which means I can divide them by 2. So 8 divided by 2 is 4, and 10 divided by 2 is 5. So that would reduce down to 4/5. All right, let's go the other way. Let's start with some fractions. All right, so if I have a fraction, let's say 12 over 50. Let's say this is my probability, and I want to change this to show it in decimal form and also percentage form. Now, a denominator like 50 makes it a little bit easier, because if percentages are out of 100, then I could just change this to something that's out of 100, and that will make it easier to work with. So think about kind of going the other way. Instead of reducing this, I want to change it so that it has a denominator of 100, which means I can multiply by 2. So 50 times 2 would be 100. Whatever I do to the bottom, I'm going to do the top. So 12 times 2 is 24. So I already have the fraction form. 24 over 100 now makes it easy to turn into a percentage. So that would be 24%. And easy now to turn into a decimal, which would be 0.24%. Okay, so easy denominators do in fact make it a little bit easier to work with. Now, if I have something that's a little bit crazier, all right, so let's say I have 5 over 18. I do not exactly know how to change that to put it into a fraction that's going to be easy to work with. I can't get the 18 to just turn into a 100 easy by working with multiplying. But the good thing is, your calculator will help you with all these types of questions, all right? Anytime you have a fraction and you want to take that fraction and change it into a decimal, you can on your calculator. So whatever calculator you have right now, grab it and just try typing that in. Remember that a fraction line means division. So you can type in 5 divided by 18, and it's going to give you a decimal. All right, so you should have 0.2777, and it just keeps going. Now, depending on your calculator, it'll probably round the last spot. You might see an 8 there, and it's not truly an 8. It's just the calculator can't fit anymore, so it's going to round the last spot that it sees. So what this is just 0.27, and then the 7 goes on forever, okay? So that's not something I would have been able to easily get by working with the denominator of 100. This is a harder fraction. But if I needed to show this as a decimal or as a percentage, your calculator is the way to do that. So 0.27, where the 7 repeats, I could say that that's approximately, let's say 27.7. And I'm going to say that keeps going, right? If I needed to, I could round it to 2 places, let's say 0.78%. Okay, or as a decimal, it's just 0.27, which you already have from your calculator. Okay, so the rounding directions, the way that they write them, you'll kind of know that from the directions, or if it's a multiple choice styled question. So you should be able to go back and forth between fractions, decimals, percentages in order to show those calculations. Okay. Any questions on those, working with decimals, percents, fractions, before we keep going? Or are you all good? Awesome. Thank you, girls. Okay, perfect. All right, so that's just kind of some behind the scenes of the math part that you need to know for the probability. Let's head back to the actual probability terms. All right, so PowerPoint should be up back again here in a second. There we go. All right, so fractions, decimals, percentages. Oh, wait, I think that's still connecting. There we go. All right, so that is how your answers and probability are going to be shown, okay? Always. Probability is based on one of those things. All right, now these are some of the must-knows that you should understand of just working with probability. You're going to see a lot of questions that deal with these two things. The coin toss, we already talked about a little bit. So every coin has two sides. One of them is heads, one of them is tails. The deck of cards. The deck of cards is something they kind of assume that you know. If you don't know this, maybe you want to jot it down, or of course you could Google this, but they're going to ask you a lot of probability questions dealing with cards. So you should know what makes up what they call a standard deck of cards. All right. So there are, and say, take out the jokers. All right. We're just working with your standard cards. So you have 52 cards in a deck, which means every question that you answer is going to be out of 52 because there's 52 total cards. All right. In those 52 cards, you have two colors, red and black. It's half and half. So that means you have 26 cards that are red and 26 cards that are black. All right. Also within a deck of cards, so if you're not familiar, just jotting this down again, you have four suits. So those four suits, you have clubs, you have spades, you have, and how funny that I'm trying to remember all these. Help me, what else? Clubs, spades.
Diamond, heart.
There you go. Those are our red ones. Hearts, diamonds. All right. So with those suits, you have two suits that are red and two suits that are black. So I started with the black, the clubs and the spades. Okay, those are your black deck or your black suits, and then the hearts and the diamonds, those are your red suits. Okay, so in each suit, then that's kind of divided equally, which means you're going to have 13 cards of each suit. So you have 13 clubs, 13 spades, 13 hearts, 13 diamonds. Each suit is going to have the cards 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, King, Ace. Okay, so that means you should be able to figure out any combination of things that they ask you. Black, red, suits, the face cards. Those are your jacks, your queens, your kings, your aces. So they're going to ask you probability questions based on those. So you really need to know the makeup of the deck of cards. Okay, let's look at some examples with those. So I don't want you to answer these out loud or in the conversation bar yet, but take a second and try to write these down. And I just want you to give me an idea of how you know how to answer these at this point. So what is the probability of, and go ahead and answer part A, part B, part C. And I'll check back with you in a minute. All right, let's bring this back here. So I'm going to ask a couple of you here to answer those questions, and I'm actually going to go in the order of my screen. So Megan, you're going to luck out. Tatiana, why don't you go ahead and type in the answer for part A in the conversation bar? Abby, why don't you take B? And Bonnie, why don't you take C?
Lost the screen, so I don't know what C is.
I'll bring it back for you. I just had to pull up the conversation. And you can answer in any format. So it can be a decimal, it can be a fraction, it can be a percentage, whatever's easiest for you. Obviously, the fraction line would be tough to type in, but you can use the words out of. right, so let's see. I've got, all right, Abby, you lost the screen. Each time I have to switch to the conversation, sorry, it kind of pops back. I can keep this up for another second, but Tatiana, you answered 1/2 for part A. That is correct. I'm going to pull the PowerPoint back up again. So flipping a head on a coin toss, remember that is 2 sides, the head is 1 side, so your probability would be 1 out of 2. Now, would that, for part A that Tatiana just answered, is this considered, let's go back to those probability terms, and you may have those written down in front of you. Would this be considered an empirical probability, a theoretical? Which one do we think? And you can type or talk. Empirical or theoretical?
Theoretical, because you're just
Theoretical.
Very good. Yeah. And I don't think, Tatiana, I don't think you picked up a coin and tossed it, right? You were just telling me this is the probability of what should happen. What should happen is your theoretical. Very good. And all of these that we're answering right now are theoretical because these are cut and dry. This is just the makeup of a coin. This is the makeup of a deck of cards. Okay. All right. I'm going to pull up my conversation again, so you might lose the PowerPoint here for a second. All right, Abby, so your question was the probability of choosing red, and that would be correct. Now, if you just answered out of 52, and maybe you thought about that first, would be 26 out of 52, right? Half the deck is red. So you could say 26 out of 52, the reduced version would then be 1/2. And you can go right to the reduced version anytime. So that's absolutely correct. Nice job, Abby. All right, Bonnie, I'm going to pull back up the screen if you want to try this again, if you can see it. But this was just, what's the probability of choosing a queen from a standard deck of cards?
Would that be 4 out of 52?
Yeah, very good. Okay, so there are 4 cards that are queens, and there's 52 cards total. So 4 out of 52. What would be the reduced answer? And anybody can jump in if you'd like. 4 over 52, reduced.
1/13.
1 out of 13. Very good. So you should be able to answer, again, the typical, here's exactly the numbers that I'm using because this is the number that I have, and the reduced versions. Good. All right, let's do a part D here. And Megan, you're going to be up. So I'm going to type this in, and I'm going to give you a little bit of a harder one. Okay, and everybody else think about the answers, but I'm going to have Megan answer this one. Now, whenever you're ready.
1 out of 26.
Okay, good. Now, what would be the answer before you reduced? Can you tell me that part?
2 out of 52.
Good. Yeah, so this is your straightforward. There are 2 blackjacks out of 52 cards, right? This is your theoretical, just this is how it's made up, right? Reduced version just goes down. You're absolutely right. 1 out of 26. Nice job. All right, so those are your specifics of how to answer. Now, we answered all with fractions, but you could take all of those and change them to decimals or percentages if you needed to. Obviously, the 1/2s are going to be the easier ones. You could answer those as 50% or 0.5. Anything else, I go right to the calculator, type it in as division, and see what that turns out to be. Okay? All right, so let's look at some kind of key vocab. This is where it's going to take it up a notch from your just basic vocabulary with probability that, you know, anybody can answer outside of a math class versus, okay, you probably only remember this stuff if you're in math, right? So we're going to talk about keywords that you see, and, or, not, for, against, and then how many different ways. So maybe jot these terms down as well and what they mean, okay? The first one is and. So example would be, what is the probability of choosing a card that is red and a jack? So they're asking you for 2 conditions to be met. So that's an example question. You don't necessarily have to answer it right now, but I'm just giving you an example. So and means it's a more specific type of situation. Another thing, which we haven't talked about too much, but is rolling a die. All right, you may say, what is the probability of rolling? Let's say you take 2 dice, right? And what's the probability of rolling a 4 and a 6? So this is kind of the combination of both of these things happening, not just one. Sorry, little one's going again. All right, so keyword is just and you need to remember that and means multiply. So you would be figuring out the probabilities for each thing happening, and then you just multiply the 2, which means we need to know how to multiply fractions, okay? Which we'll talk about in a second, and we'll look at how the calculator can help. All right, or. So if you see the word or, this means that you're going to be adding. So the or means that there's going to be, I guess, more chances of this happening because we're not saying that both have to happen. We're saying that either one could. So this would be an example of what is the probability of choosing a red card or a queen. So if I can choose a red or a queen, that means there's more ways that that could happen, which means the probability is going to be greater. Okay, so or means you're going to add, which means we need to know how to add fractions. Okay, so that's going to be a topic. All right, not. Not means, that's pretty straightforward, the probability that something is not happening. So basically you want to look at, well, what's the probability that it would happen, and then see what's left over. So not is going to deal a lot with kind of the idea of subtraction, but it's more of, I think most people can just kind of do that in their head. The easiest would obviously be, you know, working with those things that are equally likely. So if I say, what's the probability of you not flipping heads? That's basically the same thing as me saying, what's the probability of you flipping tails, right? Those are the easiest scenarios. If I'm thinking about a deck of cards, easiest scenario, what's the probability of you not choosing red? That's the same thing as saying, what's the probability of me choosing black? Because again, cut and dry, okay? You could get more specific. What's the probability of not choosing a king? Well, that means there's all of the other cards that you're looking at the probability that you are choosing. So if it's the probability of you not choosing a king, then you're just taking 4 cards off the list, right? So we're saying the probability would be all the other cards that are left. So 48 out of 52. So not, a lot of times too, I'm going to use the weather, for example. They may look at what's the probability of it snowing today. Okay, probability of it snowing is 20%. So what's the probability of it not snowing? 80%. So it's just what's left over. Okay, the word for and against. For, we're saying what's the probability that it will happen. Against, what's the probability that it will not happen. We're going to look at some voting types of examples, and you're going to see that a lot, where they may look at the probability that people are for the candidate and the probability that they are against the candidate, which is just looking at, again, the difference between the two. All of those that we just went through, and or not, for and against, all of those are going to be answers that are fractions, decimals, percentages, just like what we talked about. This last one is a little bit different. So this is going to be how many different ways, and I want you to watch for those words. Anytime you see those words, you should not have a fraction answer. You should not have a percentage or a decimal answer. This is truly going to be a number, so just a whole number of how many different ways something can happen. And we're going to go through some examples of those too. My little trick, I guess, is to set up what I call chairs, and you just multiply them, okay? Not a fractional answer. I'm going to give you another minute. Just make sure that you have all those terms down and the little summary that we just went through of each one, and then we're going to try some of the math that goes along with this. So multiplying fractions, adding fractions. I'll give you a sec, and then I'll pull up the whiteboard. All right, so whiteboard should be coming up there in just a sec. All right, so we're going to go through the math behind it, so looking at how do I multiply fractions and how do I add fractions. Now, going back to the calculators that I know some of you have. Tatiana, the calculator that you had before can do a lot of the stuff with fractions. You should have a fraction button. Okay. The other calculators that you're using, if you're going to use the calculator on your phone, depending on the phone, it may have a fraction button, it may not, but there's always ways that you can type fractions into calculators. The problem is most calculators are going to give you decimal answers, not fraction answers. Most probability questions are going to want fraction answers. So unless you have a calculator that you can type in fractions and get answers that are fractions, you may not be able to use the calculator too much to help you with the full problem. Okay? So let me give you a couple examples. So if we have, and I'm going to multiply first, multiplying fractions. So let's say we've got 3 over 4, and I'm going to multiply that by 2 over 5. All right, multiplying fractions, you just want to remember that you're going to multiply the tops and you're going to multiply the bottoms. Multiply tops, multiply bottoms. So if I multiply 3 times 2, I get 6. And if I multiply the bottoms, 4 times 5, I get 20. That's what you need to know how to do, because the calculator, if you just type in 3/4 times 2/5, it's probably going to give you a decimal. Now, you can type it in, like I said, if you have the fraction buttons. You can even type it in if you don't. The way I would probably do it, you should have a parenthesis, whatever calculator you're using. It would be parentheses 3 divided by 4, close it, times parenthesis 2 divided by 5, close it, and it will give you an answer. Try it with whatever calculator you have right now, or if you have the fraction buttons, you can even do that too. Let's see what it gives you. The fraction button on the calculator, it probably looks something like this, Tatiana, the one that you have, I'm guessing, if you can find that. And I'm trying to remember exactly what your calculator looked, but I think you might have something like that. Okay, so then that would show you what you're going to type in the numerator and what you're going to type in the denominator. So for example, you would do 3, 4, and then hit your divided button, or I'm sorry, your times button, and then go get that fraction option again, and then type in the 2/5. So if your calculator has that, it will probably give you this 6/20, or it may give you the reduced answer right away. Okay, now I'm going to go back. If you typed it in just on the calculator, the 3 divided by 4 and then times the 2 divided by 5, you should have gotten a decimal answer of 0.3. And the decimals don't show up very much when I do that, sorry. So that's 0.3, okay? That's not exactly the way that I got this, my 6/20, but if you kind of watch, what I'm going to do is reduce this 6/20. They're both even, so 6 divided by 2 is 3, and 20 divided by 2 is 10. 3/10 is what I get as a reduced answer. 3/10 is the same as 0.3. Okay, so you are going to get it, but you may need to kind of change it into a fraction. If it works out real ugly, though, as a decimal, that's not going to be something that's easy to convert back and forth. So you absolutely need to know how to do this. Okay, multiply tops, multiply bottoms, so that way you can handle any type of fractional question that you get. Okay, so knowing how to multiply tops, multiply bottoms. That's the first key. All right, now let's look at adding. Adding fractions is a little bit more involved. When you are adding fractions, there's a rule. Anybody remember this? What you have to have before you can add?
Same bottom.
Very good. Common denominators or same bottoms, right? So that is the key for this. Now, the cool thing about probability is usually you will have common denominators, okay? Because you're dealing with the same overall amount of things. So if you're dealing with cards, you're dealing with 52 cards. That's the nice part about not reducing. So that way you can actually have common denominators all the time without having to do extra work, okay? So if you have common denominators, it should be easier to handle. I'm going to stick with that 52 for a second so you can see. So let's say I have 26 out of 52, and I'm going to add, because maybe the question said or, and I'm going to add, let's say, 2 out of 52. I would keep my denominator, and I usually write that first so I remember, and then all you do is add the tops. So 26 plus 2 would be 28. And that may be the answer the way that they want it listed, or they may reduce it. So you could keep it 28 out of 52, or if you need to reduce, I would say that both of these are even. So I'm just going to make it easy and start dividing by 2. If you know something bigger, you can do it. It'll be quicker. But I say don't bother, I guess, wasting your time trying to come up with something. Just keep doing this. So that would be 14 out of 26. They're both still even, so I'm going to go again. 14 divided by 2 is 7, and 26 divided by 2 is 13. So then I would get 7 out of 13. Okay, let's try adding without a common denominator. So if I have, let's say, 4 over 13 plus 1 out of 52. So my denominators are not common right now. I'm going to try to make them common. So I need to think about counting by 13s, counting by 52s, until I get something that matches up. We call it the least common denominator. Now, you can always try to find the least common denominator, or in general, you can just find a common denominator. It doesn't necessarily have to be the least. Finding the least common denominator makes it a little bit easier. That's all, okay? You'll be dealing with smaller numbers. So if I count by 13s, I will eventually get to 52, which means I could just use 52 as the common denominator for both of them, okay? And that number 4 that you're thinking of, Abby, that's going to help because there are 4 13s in 52, right? When you worked with these originally, what you would say is, whatever I do to the bottom, I need to do to the top. To turn this 13 into a 52, I have to multiply it by 4. That's why that number 4 is in your head. Whatever I do to that bottom, I'm going to have to do to the top. So 4 times 4, this would turn into 16 out of 52. So what that means is that these two fractions are equivalent, okay? And to prove that to you, you could type them in your calculator. If you type in 4 over 13, which just means 4 divided by 13. And if you type in what we just got, 16 over 52, so 16 divided by 52, you're going to see that the decimals that you get are exactly the same. And what that means is you did it right. These are equivalent. All right, so that turns into 16 out of 52. The second fraction already had a denominator of 52, so I'm not going to touch it. I'm just going to keep it. So 16 over 52 plus 1 over 52, now it's just like the top question. I have common denominators. I can go ahead and just add my numerators. So 16 plus 1 is 17 out of 52. Okay, and then I would try to reduce that if I needed to, but if you remember what I said about that number 17, it's prime, so I can't really do anything there. Okay, so those are two examples of adding. Now, you're not always going to be dealing with these denominators, of course. You're going to be dealing with all sorts of crazy stuff. So you need to be able to, I guess, handle anything, any type of denominator. So I'm going to try a super weird hard one just so that you can get the idea. Okay, so we're looking at not common denominators. So let's look at 6 over 21 plus 5 over 20. Okay, so I need to add these. I need common denominators. I do not feel like counting by 21s and counting by 20s until I get to something common, and I don't exactly know what it is in my head right now. Okay, so this is where I say you can try to get least common denominator, or you can just get common denominator. Does anyone know the easiest way to just get a common denominator?
Multiply them together.
You got it. Very good. Okay, so when in doubt, multiply them out. That's all you need to do. I'm not going to sit here and waste my time trying to figure out a least common denominator. I know that if I multiply 21 by 20, whatever that number is something I'll be able to use. So I'm going to do that. 21 times 20, and I have 420. So yes, you're going to deal with bigger numbers, but at least it's going to work. Okay, so I'm going to make each denominator 420. So to change that 21 into a 420, I had to multiply it by 20. So whatever I do to the bottom, I have to do to the top. So 20 times 6, which is 120. If you want to check your work, you can always type them in to make sure they're equivalent. So you could always type in 6 over 21 and then type in 120 over 420. All right, second fraction, I need to change that into a denominator of 420. So that means I multiplied 20 by 21. So same to the top. 21 times 5. And we get 105. So now that I have common denominators, now I can add. So I'm doing the exact same thing. It's just one that I wasn't able to quickly get to by doing a least common, which means multiply them out. Make it easy on yourself. So now I can add them together. I'm going to keep that denominator. So 120 plus 105. So we have 225 out of 420. This could be reduced, okay? And if you're dealing with higher numbers, it's going to take you a little bit longer to reduce, but you'll get to it eventually, okay? Good trick as well, if you're dealing with these in multiple choice questions, do that little equivalent thing that I showed you on the calculator. So if you type in 225 over 420 and see what the decimal is, you could always just test out each one of the multiple choice questions and see which one matches up. Good test taking strategy, okay? But let's go through the reducing. So what I notice is the first one, 225 ends in a 5, and 420 ends in a 0. If something ends in a 0 or a 5, that means you could either count by 5s or count by 10s. Knowing that one of them is a 5 and one of them is 0, I'm thinking count by 5s. So that means each one of these has to be divisible by 5. So I'm going to do 225 divided by 5. That's 45. Over 420 divided by 5, that's 84. All right, so this is my reduced answer, 45 over 84. Now I'm going to see if I can go down any further. They're not both even, so I can't divide by 2. 45 can divide by 5, but I don't think the 84 can because it doesn't end in a 0 or a 5. So maybe you want to try something like 3. All right, so I'm going to try 45 divided by 3. That works. 84 divided by 3. That also works. Okay, so I'm dividing each one by 3. So I get 15 over 28. So now I'm dealing with some lower numbers. All right, they're not both even, so no 2. Not 5s or 0s. Okay, so it's not 5 or 10. So maybe I'm looking again at maybe I could divide by 3 again. Well, 15 divided by 3, that would work. If I do 28 divided by 3, that's not going to work though. I get a decimal. You may kind of test out some other things, but if 15 over 28 is listed, you're probably just going to pick that. But you could test around a little more. So 15, the only things that go in would be 3 and 5. Can't do that for 28, so that's it. 15 over 28. Okay? All right, so that's multiplying fractions and adding fractions. Those are the topics that you would need to use for those probability type of questions. All right, I am going to, let's see, head back to our PowerPoint here for a second. All right, so the other terms that are here, I don't know if that's sharing still, one sec. All right, PowerPoint should be back up there in a sec. All right, so now that you know how to work with those, so let's go back and look at where you would use them. So and means multiply. So if they're asking a probability question that has the word and, you would come up with the probability for each one and then multiply the fractions. If they ask you about or, then you're going to come up with the probability for each one and then add the fractions. All right, the nots are a little bit easier. You're just taking the difference. For and against, that's just kind of helping you, understand which one of these you're doing. The probability that will happen, which is just your straightforward, like theoretical probability. The against is the probability that will not happen. So it's kind of going back to that idea of not. We didn't talk about the how many different ways just yet. Okay, so I'm going to go back and look at that one right now. So how many different ways shows you a total number of the amount of options that are possible. Okay, so if I were to say, this is a silly example and you'd never be asked it, but just to show you, what's the probability of choosing a card from a deck of cards? The probability is technically 1, right? Because obviously you're going to pick a card. If I said, how many different cards can you pick when you pick a card from a deck? There are 52 cards. It's not a probability type of question. It's just saying how many different options could you get? Okay, how many different things could happen? So we're going to look at a lot of examples where you're going to be doing multiple types of things that they're going to ask you about. I'm going to pull up a whiteboard again. A common example that we see a lot with this is dealing with food. So I'm going to use that one as my example to show you. Let me get that whiteboard back up. Okay, so let's say you go out to eat, which I'm sure a lot of us are missing right now. So I sit at this restaurant and I'm looking at the menu and I decide I'm going to choose an appetizer. And I'm going to set up a little chair for that. That's what I call this. So I'm going to choose an appetizer. I'm going to choose an entree. And I am definitely going to have dessert. Okay, so these are the 3 different things that I'm going to get: an appetizer, an entree, and a dessert. Now, I want to figure out how many different possibilities, how many different combinations are there of what I could actually get. So by looking at this menu, and my husband always yells at me because I take so long to pick out what I'm going to get, and I tell him, probability says here that there are so many different combinations of what I could get, it's going to take me a little bit to figure this out, right? And the reason is because if I choose this appetizer, well, maybe I want this entree. And if I have this entree, maybe I want this dessert. All the different combinations of these things. So let's say I'm looking at the menu, and the menu has 12 different options for appetizers. All right, for entrees, let's say there are 36. And on tonight's menu, they have 8 different options for desserts. Okay, so what I'm filling in each chair, as I call it, is the number of options for each one. So there are 12 options for appetizers, 36 options for entrees, 8 options for desserts. If I want to figure out how many different combinations of this would there be, how many different meals could I get? Okay, well, if I choose, let's say, appetizer number 1, and entree number 1, and dessert number 1, there's one possibility. But if I choose appetizer number 1, entree number 1, and dessert number 2, there's another possibility. You see how this could keep going like for a very, very long time? Okay, maybe I choose appetizer number 1, entree number 2, dessert number 2. There's another possibility. Now, instead of doing this, because this would take me forever to list all of these different possibilities out, they say you can just figure out the total number of options by multiplying. So all I'm going to do is take 12 and multiply it by 36 and take that number and multiply by 8. And this is going to tell me how many different meals could I make when I have 12 appetizers to choose from, 36 entrees, 8 desserts. So you're going to multiply 12 times 36 times 8. And this tells me that there are 3,456 different meal possibilities that I could get if that's what's on my menu. Okay? And this is why I tell my husband, it's going to take me a while. There's 3,456 different options here, right? So it takes a bit. So this is not a probability. This is a how many different. So I want you to understand the difference in the wording for these types of questions, okay? Probability answers will be fractions, decimals, percentages. If we say how many different options are there, this is what you're doing. Set up your chairs, multiply out the numbers, okay? All right, and with that, guys, I think this would be a good time to take a little break before we go into some real true probability example questions, okay? I'm going to, hold on, stop sharing for a second and come back to my screen. Give me 1 second. There we go. So before we take our little break, are there any questions that you would like to ask me so far? Feel free to comment or jump in with your audio.
Nope, this stuff I get.
Awesome. All right, so I am going to, when we come back from our break, we're going to go through some example types of questions that work with tables and are more of that empirical type of probability, where they're saying, here's what happened, tell me the probability now. Okay, so we'll look at some examples with those. And we're also going to talk about Venn diagrams. So that's going to be the rest of the big topics for the week. Okay, so we'll talk about those in a little bit. Tatiana, how to use the calc for a fraction like that. So you would always do the fraction with division. So you would do 3 divided by 4, or again, you can use your fraction button if you have that on your calculator. Okay? And if you need more help with that, I can help you when we come back from the break. Okay? Everybody else okay? All right, let's see. My clock says 10:25. Why don't we come back about 10:40-ish? Are we okay with that? Take a quick bathroom break, fill your coffee, whatever you need to do, check on your kiddos, and we'll come back. So reconvene about 10:40. Okay, so about 15 minutes. I will see you back then. Hello, everybody. Give me an okay if you are back with me, please.
Hello.
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 Hi there. Awesome. I think just Tatiana. There we go. Awesome. Hi, everybody. All right. So hopefully you got a chance to take a little breather there. I want to go through 2 more topics, and then that'll be it. So then I can hang out for a little bit. If you have questions or need help on anything, you're welcome to do that. We already talked about what you need going forward for week 4. And then again, I'm just going to remind you, try to work ahead if you can, so that way we're not crunch for time at the end. I am hopefully going to find out more information on Monday. So expect some announcements or emails from me probably Monday or Tuesday about the end of the session. And then I'm going to try to go through and I guess kind of see what's left for you and maybe try to adjust the dates if you need to. Remember that we don't have a typical like day by day tracking because nothing is due on a specific day, especially with us having class on Saturdays. So not a tracking calendar per se, but you have your course outline that just shows you what needs to be done in each week. So please use that, look ahead. I can email it a copy again if you need that, but that course outline just shows you everything that needs to be completed within each week, but I'm not giving you day by day due dates for the week because again, everyone's lives are different. We're just trying to finish everything by Saturday if you can, okay? But expect more announcements from me on that front, Monday or Tuesday. All right, let me share our PowerPoint again, get back to that. Okay, so the next thing I want to talk about is working with a Venn diagram. And hold on, let me just make, there we go. That should look better. Okay, there we go. All right, so with the Venn diagram, this is something that hopefully you remember working with a while back, but you're going to see some Venn diagrams this week, and they're going to show you a couple different examples of what Venn diagrams could look like. The one that I have up here is probably the one that you would typically think of what a Venn diagram looks like. You have two circles. The two circles represent two different things, okay? Could be anything. You're going to look at jobs. You're going to look at male versus female within certain careers. You're going to look at people that have certain skills based on careers. There's going to be lots and lots of different examples that you're going to see with Venn diagrams. But the general idea of it is that you have however many of circles, depends on how many things you're talking about. So if I'm talking about two things, then I have two circles. What is in one circle? So if I look at this first example, A, all right, this shows you how many things represent A. And then in B, it's going to show you how many things represent B. Now, if it falls only in A or only in B, you're going to see those things represented to the left or to the right. What's in the center, where the circles overlap, those are going to be things that fall within both categories. So let's say on the left in A, this represents women. And on the B, this represents lawyers. Okay, so B may represent how many lawyers, and I'm just going to be real specific, are in the city of Amherst. Okay, and A is going to represent how many women are in the city of Amherst. The part in the center is going to show you how many women lawyers reside in Amherst. Okay, so that's going to be the combination of the two. So if they're only a woman, then it's going to be in that section. Maybe it's only a woman but not a lawyer. If it's only a lawyer but it's not a woman, then it's going to resolve in that section. Okay, so it's going to show you kind of the overlapping sections and the separate sections. Now, what the rectangle is going to show you, this is going to show you the things that don't necessarily fall in either category, or in some cases they're going to show you this is just the total. So in some cases they're going to figure out the total for you. You may see that number outside, and in other cases, they're going to show you the description of what that number outside represents, and you'll see those examples as you go through it this week, okay? I'm going to pull up the whiteboard again, and I'm going to show you a couple drawings and some examples of diagrams that we see that deal with the different types of Venn diagrams. Let me pull that up a sec. So that most common example that you just saw with the two circles, okay? So this is showing you two separate things, and where they overlap means that they have both of those in common. All right, now I want you to tell me, and you can either type or speak, what do you think it would mean if you have the two circles like this?
There's nothing together.
Very good. Yes, Megan. So that would mean that there's nothing in common, okay? So going back to that example that I just used, if you show the data in this type of Venn diagram, that would mean that there are no women lawyers in the city of Amherst, okay? So that's called your two circles are being disjoint. They're not connected whatsoever, which means they don't have anything in common, okay? When those circles get closer together, like in this picture, now you're looking at this is the section where two things are common. Okay, so that's one example. Here's another one, and this is probably one of the weirder ones, but you have one circle, and then you have another circle completely inside of it. Think for a second about what that might mean. Can anyone try to explain what this might mean if this is what your two circles look like? And if you're really not sure, that's okay. You can put a question mark in the conversation.
There's a group that's just all that's in there.
Can you maybe come up with some type of example? And this can go to anyone, not just Megan. This is probably the weirdest one. Now I'm going to use some letters, and if you're still thinking and brainstorming, that's okay. I'm going to use some letters so that we can easily refer to this. So let's say that the outside circle is A, okay, and the inside little circle here is B. What does that mean about B in comparison to A?
It's a smaller group, but they're all inside.
Good. Yeah, that would make sense, Bonnie. Absolutely. So B is a smaller group than A, but all of B is included within A. That's absolutely right. Very good. Okay, so we're not saying that they only have a portion of things in common, right? We're saying that everything that B has is kind of within A. Okay, this is probably the weirdest scenario that you're going to see, but what we call it is a subset. Okay, and if I could give you a math example, I feel like that makes a little bit more sense. So let's say that A just represents whole numbers, natural numbers. You may even see that word as you start to work through your work this week. So let's say A represents the natural numbers. Natural numbers, think about when you first learned to count. When you first learned to count when you were very, very little, I would say it's only natural that you start counting at the number 1, right? Little kids don't really necessarily understand the concept of 0 yet. So let's say A represents like 1, 2, 3, 4, and so on. And it keeps going forever. Okay, these are called the natural numbers. There's no decimals, there's no fractions, there's nothing like that. Okay, so let's say A represents all the natural numbers. B is going to represent a subset of those numbers. So it's saying B is not going to be every single natural number, but it's going to be some of those natural numbers. They're all natural numbers, but it's only going to be some of them. So maybe B is going to represent just the odd natural numbers. They're still all natural. They're still all part of A, but I'm not saying it's every single one. Okay, they don't have every single thing, but at least they're all natural. So B is going to represent the numbers like 1, 3, 5, and so on. So it's saying that if I took set B, all of it is in A. So it's not just a portion of it that's in common, they're all common, but B is representing a subset of those numbers. Okay, now we see these in real examples with jobs, careers, and things like that, but they're a little bit harder, I would think, to come up with a real world example, and that's why it's easier to explain these things with numbers. You'll see all of these different Venn diagrams within your work this week. For the most part, they're not going to ask you to apply these numerically. They're not going to ask you how many are in each section. They're just going to ask you certain situations and ask you which picture represents the data the best. Okay, so you just need to understand what each one means. Any questions on the Venn diagrams? I know that's a brief overview. All right, I'm going to bring us back to our PowerPoint, and we'll start looking at our next topic. So B in that example that I gave you would be, I just came up with an example and said that they would be the odd natural numbers. So something like 1, 3, 5, 7. So everything that's in B is also in A. That's what it would mean. Okay, so the subset, I guess, is what you would call B. So it's a subset of A, which is just taking certain values or certain members from the set of A. All right, so back to the PowerPoint. We're going to look at probability from tables. So this is going to be our last topic for today. When you are given a table, okay, the table could mean a couple different things. Maybe they went through some type of experiment, some type of trial. And if you remember back in the first set of vocabulary, we looked at theoretical, empirical, and subjective. Tables are often used to show the results of an empirical trial. So empirical, remember, means what would actually happen. This is what you're going to do, again, in your project, the standard coin report. So the standard coin report, you're actually going to be creating a table, and it's going to show the empirical probability. So the results of your trials. So you'll be flipping a coin a certain number of times, and you'll be inputting that into a table to show what happens. So this is going to be the empirical. So we often need to answer probability questions from the results, okay, from the table. So we're going to look at an example of that, using the table to answer the questions. We are also going to see types of questions where they're looking at opinions, facts, surveys, things that they're pulling data and representing that data in a table and then asking us certain types of probability questions from those, okay? Here are my two kind of keys for any question that you have like this. You need to have a total, okay? That total is going to be your denominator of your answer. So when you answer a probability question, so anytime they're saying, what is the probability of? You should be thinking fractions, decimals, percentages. Those are the types of answers that you should have. I would recommend doing fractions first. Regardless of what they ask you for, the fraction is usually the easiest one to get in terms of probability. So get the total, that will be your denominator. Answer it as a fraction. So think about the words out of, okay? Answer it as a fraction, and then if they ask you to change it to something else, as a decimal or as a percentage, then do that. But the first thing that you should do, what's the total? Answer it as a fraction. Okay, so I'm going to pull open a document here so you can see what I mean, and we're going to try a couple. I actually did attempt to share this in the chat. I don't know if that worked, but I tried. So these are 3 probability questions. Let me make sure that that's sharing the right one. Give me 1 sec. I don't know if it's sharing the right thing. Hold on. I think that's the right one. All right, can everybody see the probability questions here? The first one should read, a radio station did a survey. And can somebody just say yes so I don't have to switch again?
Yeah.
Okay, thank you. All right, so first question, this is an example of a table where they're collecting data. Okay, so this is collecting data where they kind of perform some sort of survey and asked questions. All right, so there's an example of a table. Number 2 is a poll. So this is a public opinion poll. They're broken down into categories. They're showing you for, against, and no opinion. So again, this is a type of survey or a poll where they're just collecting the data, showing it in a table. This third one, this is that more of a trial type of thing where they're showing you, here are the results of what I did. I rolled the die and here's what happened. So this is more of along the lines of that empirical probability. Okay, let's actually start with this one. So this is going to be kind of similar to what you'd be doing with your standard coin report. This is working with dice, but it's the same idea. So 2 cubes with sides numbered 1 through 6 were rolled 20 times. Their sums are recorded in the table below. So rolled a die, looked at the 2 that were on there, and they took their sum. They added them together. So in the first trial, you can see that there was a sum of 4. Second time, a sum of 9. Third time, a sum of 8. And this is the sums of all 20 times that they rolled those dice. So what is the empirical probability of rolling a sum of 9? So the difference in the wording of this, they are not asking you what's the theoretical or what is the classical probability of rolling a sum of 9. If I wanted theoretical or classical, that would be listing out all the possibilities, the true possibilities of getting a sum of 9 and saying what is the probability that that should happen. Empirical probability says don't worry about what should happen. Let's look at what did happen. So if you actually did this trial and they want to know how many times, basically, did you get a sum of 9 and what's the probability then of that happening. So total, I need to figure out the total number. Well, that's 20 because there were 20 different times that they did this. So 20 is going to be my denominator. The empirical probability of rolling a sum of 9, so I need to see how many 9s occurred. Okay, so if I go through the table, we have 1, 2, 3, 4, and 5. I think I got all of them. So it looks like 5 times what actually happened when they did the trial. 5 times they got a sum of 9. So that means my probability would be 5 out of 20. And 5 out of 20 is listed as choice 2. Now, maybe they would have reduced that and I would have had to check. But as a multiple choice, if they list it just like that, you're safe to say that that's your answer, 5 over 20. If maybe they would have listed this as 1 out of 4, that would be the reduced answer. Very often with empirical, they'll keep it as this fraction because they want you to see the real numbers. So by looking at 5 over 20, you know that it occurred 5 times out of the 20 trials. Okay, so that example right there, very similar, like I said, to what you're going to be doing in your standard coin report. All right, let's try some of the other types of table questions. So back up to number 1. A radio station did a survey to determine what kind of music to play by taking a sample of middle school, high school, and college students. They were asked which of the 3 different types of music they prefer on the radio: hip hop, alternative, or classic rock. And the results are summarized in the table below. Now, notice how organized the table is. If you need to create a table of a survey result, okay, of questions that you asked, you should have labels. If those labels are not there, we're going to have no idea what those numbers represent. So notice the way that it's read. Middle school is all in the first row, high school in the second row, college in the third row. Hip hop in the first column, alternative in the second column, classic rock in the third. Okay, so let's practice just reading the chart. I'm not even doing the question yet. I'm just practicing reading the chart. Okay, and I'm going to ask to hear from some of you if you can speak. Awesome, so I don't have to keep switching to the conversation bar. So if you're reading the table correctly, how many high school students chose alternative?
22.
20.
Good.
Oh, 22.
Got it. Good, good. All right, how many classic rock choices came from college students?
14.
14. Very good. Okay, so this is how you can properly read. Okay, now let's look at some totals. How many total middle school students were surveyed? What would I need to do?
Add 28 plus 18 and 4.
Very good. Yep. So this is how you would get your totals, right? So if I'm looking at total middle school, 28 plus 18 plus
50.
4, 50. Very
50.
good. So that means that 50 middle school students were asked about the survey, right? All right, so now that's just reading the chart. Let's go to the actual question. What percentage of college students prefer classic rock? So notice they're asking me for percentage. But in my tips that I gave you, what did I say is the easiest to answer with first?
Fraction.
Fractions. Good. So I'm not going to worry about the percentage yet. We're just going to figure out the fractional answer, and then we'll convert it. So this is saying what percentage of college students. So they don't care about the other ones. They're only asking about the college students. How many college students were asked? So what's our total?
50.
Okay, so if you add together 16 plus 20 plus 14, 50 college students. Out of those, how many preferred classic rock?
14.
14.
Okay, so then our answer would be 14 out of 50, right? That's our fractional answer. But they're asking me for a percentage. So you could do one of two things. You could change that quickly into something that's out of 100, right? Because that wouldn't be too bad to do. Or you can just type it in your calculator, 14 divided by 50, and change that to a percentage. Either way you do it, how about an answer?
28.
28%. Very good. Yep, so that would have to be choice 2. Okay? So that's how you're reading the table, answering the percentage type questions. All right, let's try another one. Number 2. A public opinion poll was taken to explore the relationship between age and support for a candidate in an election. The results of the poll are summarized in the table below. All right, so we have the age breakdown. We have people from that age group that were for the candidate, people that were against, and people that didn't have an opinion at all. So we want what percent of the 21 to 40 age group, so we only care about that group, was for the candidate. All right, no answers yet. Everybody take a second and see if you can get your own answer before we talk. So let's take a minute or two to do that by yourselves. All right, so let's check your step-by-steps before we check your final answer. So how many people were surveyed that were in that age group?
50.
50, good. How many of those were for the candidate?
30
30. So your fractional answer,
is 30 out of 50.
very good. Now let's change that to a percentage,
And that's
60.
60%. Nice job. Yep, so that would be choice 4. So do we kind of get how that works?
no.
Who's my no? Sorry, I didn't hear that one. I gotta go back to my conversation. Hold on. All right, Tatiana. So Tatiana, I'm going to look at another example instead of explaining that one again. Let's try another one with that same table. Let me get back to it. All right, so I'm going to do an alternate example with this exact problem, though, number 2. Okay, so I'm still going to use this table. All right, and Tatiana, walk through the steps with me, okay? So if I want to know what percent of the 41 to 60 age group was against the candidate. Okay, let's try that. So we're going to do 41 to 60 group against the candidate. So the first thing I would do is see, well, how many people were asked from that age group? So if I'm only concerned with the 41 to 60, I'm going to figure out how many people did they ask. So that would be 20 people plus 40 people plus 15 people. So 75 people in that age group were asked. Okay, so that's my denominator. My denominator would be 75. Out of the 41 to 60, we're saying how many of those were against the candidate. So against the candidate would be 40. So my fraction answer would be 40 out of 75. So now if I want to know what percentage was that, then I can change it into a decimal on my calculator. So 40 divided by 75. This one doesn't work out super pretty, but it would be approximately 53%. So I could move it over 2 spots and round. Do we follow through the steps of that one?
Yes.
Yes? Okay, good. So that's the steps that you would take for each. Now, what if I just ask you a kind of more general question instead of specifying a certain age group? If I ask you how many people were surveyed, what would you need to do?
Add all the people.
Yeah, you'd have to get all of them, right? So if they're not being specific to a certain group, you need to make sure you get an overall total of how many people were surveyed or how many people were asked in this poll. Now, sometimes they'll put that information in the directions, kind of like they did in number 3, how they told you they were rolling it 20 times. But in other cases, you're going to need to figure that out. So everybody go ahead. Let's find out how many people were actually asked in this poll. So you're going to add together on your calculators all of those numbers.
200.
Okay, everybody got it? All right, so 200 people total were asked, right? So now what if we just said, what is the percentage of people that were for the candidate? So out of 200, how many said they were for? So now we need to figure that out.
So
we have
75.
75.
Good. Okay. So then it would be 75 people were for the candidate out of the 200 people total that were surveyed, right? So now if I want to change that to a percentage, 75 divided by 200.
38%.
Yeah, so it'd be about 38%. We could even say, because this one's pretty nice, like 37.5%, right? So you're going to have a table of values or a table of data that was collected, and there's going to be tons and tons of questions that they could ask you about that, because they could be asking you about different categories. They could be asking you about different things from those categories, for, against, no opinion. So you really have to pay attention very closely to the wording of what they're asking you for, okay? But the concept, the process that you're going to take is going to be the same every time. What's your total? How many from that specific category? Write it as a fraction, and then change it into a decimal or percent if you need to. Okay? All right. Any questions with those? Anything else? Good.
Yeah.
All right. Awesome. So that was the last of the main topics that I wanted to go through. The rest, I think that's the main stuff that you're going to see within the probability. There's another kind of like one of those random little topics that's mentioned a little bit that I don't want you to stress over. I'm not even going to spend time in our lecture, and it's called the Fibonacci sequence. It's a little bit in your textbook. You can Google it to help you answer the questions. Feel free, but it is not by any means a big topic of focus this week. So if you see it, just like those points that they talked about, don't be scared off by it. Google is your friend. I can help you. You can find it in your textbook as well. Okay, but we've pretty much hit on all the main topics for this week. So I will be around here for the next little bit. I'll just stay in front of my Skype if you need me, if you have questions. I'm going to continue looking at those portfolio projects. I may take a quick break just to check on the kiddos here, and then I'll be back. But I should be available for the most part for the next, I would say, hour at least by the computer. Okay, if you need me for anything. So
All right, thank
with
you.
that, thank you guys all for coming. Yep, I am going to stop the recording here in just a second. I will upload this. This is my first time doing this, but it will be uploaded to a YouTube link, and then the YouTube link will be shared out to you in case you need to go back and watch anything. Okay?
Perfect.
All right, everybody, have a wonderful
All right.
week. I will post the list for this coming week and going forward Monday, Tuesday, whatever I find out about dates. Okay?
Okay, thank you. Have a good
All
week.
right.
Okay.
You too, guys. Enjoy the rest of your weekend.
Me too.
Bye.
Bye.
With the white distance and the white top.
All right, Tatiana, you still there?
Yes, I'm here.
Okay. All right, so go ahead. So what do you need help on?
Yes, I mean, for example, we had 3/4
Okay.
multiply by 2/5. I'm using my calculator, so I type 3/4, okay?
Mm-hmm.
And now if I do this, it shows me like 4 multiplies, but have to multiply all the fraction.
I think, do you have an arrow button that you can arrow out of the fraction so that way you can hit times? So there's usually like you could arrow to the right to get out of it.
Um,
Do you have something like that?
do you mean these arrows?
I can't see, your video's not on right now, so I can't see.
Oh, sorry.
That's okay. So you should be able to arrow to the right. Usually it's in the top right of the calculator. There you go. Okay, go ahead, show me again.
3, just a second, 3,
Okay.
4. Okay, can you see that?
Oh, there. Okay, I can't see the screen, but I can see your calculator at least. Okay, so you see this circle button that you have in the middle and how it has arrows on it?
Yes.
So hit the arrow to the right.
Okay.
Got it? There you go. So
Okay.
now hit times. And now
Okay.
go to the
And
fraction again.
2, 5. Okay, perfect. I got it. Thank
There we
you.
go. Awesome. Yes. And the good thing about yours is it shows you fractions. Now,
Mhm.
the other thing that we found out last time, though, remember, is that let's say this question didn't want a fraction answer, you need to change it, right? So if, let's say they didn't list the answer as 3/10, now go ahead and type in 3 divided by 10. Type in that and let's make sure it gives you a decimal. So 3, good. Hit enter.
Answer. No, it shows me again 3
The
times.
fraction? Okay. So what I was going to try, there must be a way somewhere on this calculator to get them to not give you a fraction answer. We were trying to give you setups for this the other day. I don't know where it is though. There's a button that says mode. Do you see that to the right of the
Yes.
arrows?
Yes.
Hit that and show me that screen. Let me see what that looks like. Nope, that's probably not what we want. Okay, so you can get out of there. Just hit clear or exit, whatever button you have for that.
Okay.
Let's see. We need something that's going to convert it to a decimal for you, which without having that calculator in front of me, it's tough to... Can you maybe try to put the calculator? I know this is a pain, so I can see the whole thing. All right, so back up a little bit. Okay, let me just see what other buttons we have. Sorry for the screaming children.
It's okay.
Let's see. Okay, let's try this. Hit the AC button. It's orange. And that might clear everything out for you real quick. Or just hit on a couple times and it should clear it.
Okay.
Did that clear your screen? Okay, now the top left says shift. Hit
Okay.
shift, and then I want you to hit the mode button again, and it should bring you into the setup. Okay. All right, can you arrow down for me? Because it looks like there's going to be some more options. Okay, hit number 5, which is R and then DEC for decimal. All right, hit 1 for on. Okay, now let's try this again. Type in 3 divided by 10.
Nope, 3/10.
Ah. Okay. So that's the only thing I knew is that you could change it to a decimal. So here's what I think we're going to need to do because I don't know how to figure it without my hands on it. Maybe on your phone or on the calculator that's
Yes,
on.
I will use, yes,
So if you get the fraction 3/10, then just go to the other one and type in 3
yes,
divided by 10. Yeah.
yes, it is.
Okay.
Yeah.
So we might just need to do that. Sorry.
Okay,
Okay. But we tried.
fine.
All right. But at least you can get the fraction answers on your calculator. It's tough to do
Yeah,
that on the cell phone. So, okay.
yeah, yes,
Any
right.
other questions while I have you?
No, not yet.
All
I
right.
mean,
Sounds good.
because I haven't started working on week 4,